G'day guys and welcome back to my channel. Right, so just wanted to say thank you to Tan Meritech for having a look into the origins of the company that designs this power supply. Yes, I did know it was Australian made, but that was all I knew. I'd gone on Google and tried to look up even just like history about the company and I couldn't find anything. So I don't know how you did it. Congratulations. 10 points to you, 100 points to you, 1,000 points to you. Yeah, thanks so much. I still haven't gone looking yet. I'm going to give him a call tomorrow and see. But I went through my parts stash. So hold on. Let me just get, I've got a few things to cover here. First off, where do I start? All right. So I've got a couple of things to cover here, but I watched over the first video, and on the first video, when I first got this thing, I noticed that one of the panel meters was off, wasn't working right. So one of the LM301s was dead. Everything else was working except for the second side. The voltage was going up too high. I think the current limit was off too, but the reference diodes were all out of voltage, and yeah, that's probably why that was off just a smidge. So I looked through my stash, and you're not going to believe what I have. This is hilarious. So I got two on the table here already. But I took out of the power supply that I got, I took out 8 LM301s. And obviously one of them is dead. Well, guess what I have in my stash? One singular LM301. It's from a different manufacturer, but I know that's a good one too. Now, only one of those is buggered. So what I was thinking of doing, no, I don't want to refit LM301s back in it. I was going to put LM358s in it because in terms of all the specs, they will work really good. Bipolar technology, not JFET. They can source and sync a lot of current. They can go to the rails. They can operate single supply for the ones in here on single supply rails. They're spec'd for open loop. They're compensated for open loop internally. There's just a number of boxes that ticked it. They are a little bit faster, but still, not faster. Sorry, the input bias currents and everything are still smaller. But this is where I was wondering why they were like coming up so good compared to the other one. I was like, oh, okay, because I thought they were pretty crappy. And then I got to the slew rate, 0.3 of a volt microsecond. Well, they're not going in there then. So here's what I'm thinking of doing. Test these. Work out which 7 are good. Put them with the 8th one. Put these back in here. All the compensation capacitors were 120 picofarad and 2 of them were 68. I can watch over the video and see where the 268s were. If I can't read the font on them, they had a green dot on them, the others had yellow dots on them, I'll be able to work it out. They're also a slightly different size, so I'll be able to work it out watching the video. So what I was thinking of doing, leave all the better parts that I've put in here. So like all the lower ESR caps on the rails, on the output, the higher wattage resistors, the hard knee Zeners to replace the soft knee ones, newer faster diodes, a little snubber on the shunt resistors, the better resistors, the lower resistance emitter resistors, the base resistors I put in there. Everything that I've done, I'm going to leave. all those upgrades I'm going to leave. What I'm going to do, even the 0.1s instead of the 10 nanofarad caps. Alright, I'm going to leave all that. What I'm going to do is I'm going to test these, get a working set of 8, put them back in there, get the thing working again. Well, that's one thing I'm going to do. Now, before I go on to the next thing I'm going to do, or the thing I'm going to do before that actually, because it's currently working just with oscillation and that, but that will allow me to test what I wanted to test. Now, before I get to that, yeah, okay, so once I get these in, and their compensation capacitors in, and it's working, then, because I've got a fairly immense stash of op amps, and like for example the panel meter ones, I'm pretty sure they're single rail driven, and let's face it, 0.3 volts a microsecond's plenty to drive a panel meter. So what I'm thinking of doing is doing something like 2 LM358s for the panel meter. I might end up actually changing some of the circuitry on the input, the 4 main ones that look at the constant current, constant voltage op amps. I might end up trying to change them to something different, like I understand I haven't put too much thought into this yet. I'm going to look for something that's bipolar, but I might try something like an OPO7. I don't know how that's going to work in there, but they do work bloody good in power supplies, I can tell you that. It just depends, again, on the loop. When I say open loop, the op amps in here aren't completely really in an open loop configuration. They are in terms that they're not compensated, you know, they don't have feedback or whatever, but they have feedback through the entire loop of the power supply, through the driver and the series pass elements and the output back in. So they are in a long loop, and that's where the instability issues can arise, right? So I think what I'll do is, like I said, I'll get 8 of these working, that are working, fit them, verify it's working, then start changing just certain ones at a time. So we'll start with the 2 that drive the panel meters. I'll try and stick the 2 LM358s in there, because I'm not worried about the panel meters, like the 0.3 volts a microsecond. I don't even think you're going to be able to see the difference on the panel meter. Do you know what I mean? Like, it's almost a waste of the other op amp, but I wouldn't mind having a couple extra than one that I had in my stash, you know what I mean? So yeah, I'll try the LM358s for the panel meters, and say 6 of these that are good will go everywhere else. Then what I'm going to try and do, like I said, is try and change the input stage to like OPO7s or something like that. See if that works. See if it doesn't work. And the reference ones, I've got to have a look at what the op amps next to the references are actually doing. So if they just say buffering the reference or something like that, you know, or say they're fed by an output of an op amp, you know, that can drive some current, and then they are pulling a transistor down that's to do with the driver circuitry, I could replace them with a lot more op amps than what I could replace the CC and CV op amps that are comparing the output current and voltage against references with. So that's basically where I'm going to go from here, because I really need to hurry up and get this thing done. I need extra rails in this place badly. That's why I actually bought a couple of extra supplies, because the one I'm designing from scratch myself, that's almost finished. I got a couple of nuances that held me up. I've got this little switch mode power supply that I'm using for the fan driving circuitry in there and the panel meters. And when it's in there, because it sits over, just give me one moment, sorry. Alright, sorry about that. As I was saying, this was mounted right over a reference in my power supply, and my power supply puts out in between 50 or sometimes less than 50 to 100 microvolts RMS of noise. It's ultra quiet. And I stick this next to the constant voltage reference board in there, and it spews out noise everywhere. So I need to shield this. That's why it's out of the cover. I just had 2 screws in the back of the cover, and it was mounted like to the side of the chassis, just sitting in there, and the reference board was underneath it, and it's radiating noise into it. So I want to quieten that up and shield it. And the panel meters I ordered were injecting noise back into my reference circuitry, or sorry, the driver transistor. And so I tried getting rid of the oscillation out of them, which that worked, but I haven't I haven't tested them out and seen how they're going in the unit. The accuracy is a little bit off on them, but I'm not too worried about that so much right now. I have ordered, I don't know if anyone remembers, initially I was telling you guys how there's some 3-wire versions and some 4-wire versions. I did order the 4-wire versions, so they're coming too. So I'll try them when they get here too. But yeah, I want to get on with a few other things. I've got some low noise amplifiers I need to design some nice, really quiet power supplies for. I've got a few things to fix. I've got some amplifiers to build. I've got amplifiers to fix. I've got that mixer to fix. So I need a few power rails in here. So I bought just a single output switcher, an old one, nothing special, 30 volt, 10 amp. It's alright, it's a bit noisy. I'm going to open it up and probably put some snubbers on the switching FETs and try and quieten a few things up on it. Maybe a bit of common mode filtering on the output. I'm not too sure yet. I've got to measure it and see exactly how noisy it is. I can tell it's noisy just from the way circuits behave that I've used it to power. And I bought another power supply that's a dual channel, dual tracking, series parallel or independent one. But it's alright. It's actually fairly decent in terms of like what it is for the price. All my other supplies, like the one I built, this one and the old one, are way better in terms of accuracy than this one, but it's alright. In terms of noise and ripple, it's alright. And there's a lot of space in there, but there are a few things that I'm not too happy about. I do want to get the noise and ripple down a little bit more. Common mode, they've done nothing about, so I want to knock that off. And the heat sinks that the transistors are on, I can tell you now, there's no way that you would be able to go to, say, the last winding tap on the transformer and go down to the bottom of the voltage on that, say around 20 volts, 22, 24 volts, and pull 5 amps out of it. The past transistors will go up in smoke, I can tell you. There's like 2 D1047s, and give me a minute. Now I forgot what I was saying. Anyway, there's a couple of things I want to do, those supplies, but for now, if I can just get this up and running, and those 2 are already up and running, that'll be enough for me to do a couple of things I need to get done. Not the low noise amplifier projects and all that sort of stuff, but amplifiers and stuff like that I need to fix. I can get them done. So that's my plan from here. Now, the thing I said that I was going to do, excuse me, let me just move this NTC or PTC, I can't remember what it is, out the way. So I've had a suspicion since day one that there is still, as you guys have noticed watching the whole series, I thought initially it was going to be a few episodes and turned out to be, I think I'm up to 19 or something. I thought it was going to be an easy fix, and I mean, yeah, if I just changed the 1LM301 and had discovered all the other nuances about, you know, things being in the wrong spot, resistors being baked, wrong value pots, broken pots, caps buggered and all that crap. If I had just fixed all that crap and actually noticed half of it straight away and put an LM301 in that was the one that was buggered, then yeah, it probably would already be working. But Anyway, that's not what happened. But as I uncovered all those problems along the way, like, you know, the pots being buggered, pots being out the wrong resistance, just all those random things, when I changed the two current pots to 5K pots, the master side, it didn't change the voltage, but the slave side, it changed the voltage, which makes no sense because the constant current circuitry is a different, it's 2 op amps and a reference. Constant voltage circuitry is 2 op amps and a reference, and 2 of those op amps go into an OR gate, which controls the driver stage, which controls the series pass element, which is your output. Now, why then would changing the constant current, let's just call it a resistor, because that's what a pot is, that's in the constant current circuitry or reference circuitry, affect the voltage? That makes no sense. What's more is when you turn this thing on, the master channel comes up bang like that, as fast as it takes for a TL431 and an op amp to basically stabilize, which is literally that, it's right on 30 volts. The master channel, the slave channel, it comes up to say 29.85 and then goes up to 8.6 and 8.7, and it takes about 5 to 10 minutes to get up to 30.03, which is what I've got both sides set up. The other side does drift up 1, 2, maybe 3 millivolts over about 10 minutes and sits there, but that's just due to resistors and stuff warming up in the rest of the circuitry. There's nothing wrong there. But the other side, that's not right. That doesn't make sense to me. So, why changing the constant current pot affects the voltage? Why the voltage rises slowly? And so it got me thinking, and I thought, well, what if the constant current pot is sort of wired some, I don't know, someone lost a reference or an op amp over the years. Because remember they put a 20k pot instead of a 10k on the voltage on the slave channel, which let the voltage go up to double. And then later on I've uncovered that the only transistor that matters in the circuit was rated at 60 volts. So they put an 80 volt on the slave channel, the one that they put the voltage up double, right? Now, I don't know if that's random, that transistor got cooked and that's just what it got replaced with, or when they turned the voltage up to like 55 volts and realised there's a 60 volt part in there, they thought we should probably put an 80 volt part in there. I'm leaning more towards that. So, what I'm wondering is, did they then modify the current reference, or not modify the current reference, but do something to the wiring so that the current pot, which is 500 ohms, is across another resistor in the circuit that's got a voltage across it that's basically off of the constant voltage reference, or maybe the other current. Oh no, it can't be the other current reference because that would just affect the other half in the same way. I don't know. So what I thought I'd do is, before I start pulling it apart, pulling all my op amps out of it, putting LM301s in there, well, actually first I've got to stick them all in breadboard and test them all and work out which one's buggered. And if it is even just one that's buggered, I might not even be that lucky. But what I wanted to do, put the boards together, power it up, and all the resistors that are basically in the divider networks, all the op amp inputs, not all of them, specifically all of them bar the 2 for the panel meter basically. I want to see if there's, and I'm not talking about, you know, a couple 100 millivolts difference. I want to see if there's a drastic difference in voltage dropped across resistors, basically. In feedback circuitry and reference circuitry, stuff like that. I want to see, because that'll give me an idea. And if something is different, then I'll take the time to trace out where the wires from the pots on the master slave go to exactly on this connector, and where the pots from the current side go to, the slave side voltage and current pots go to on this connector, and make sure that's alright. Now I will say one thing, this little soldered tag that I've always been sus on, because it's soldered and I've always been like, did someone move a wire down? When I count, because the way that this connector goes on, it's symmetrical, right? So you got the negative rail there and the negative rail there, and if you look where the main board is, you'll see you've got these two fat traces here and these two fat traces at the end. So from here down is the same as from here down, if that makes sense. Incidentally, the other edge connector, I just put it together, but you can kind of see what's going on. It's the same. It's just one extra pin on one side because of the auto tracking mode. But other than that, it's a mirror image. Now, if you count the pins down, and incidentally, that extra pin is further down than what I'm getting at here. The pin that's got the solder on it, the tag, whatever you want to call it, if you count, I think it's 8, 1, 2, 3, 4, 5, 6, 7, 8, no, wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 10 down from the power rail. Or, sorry, that's not the power connector, that's the output connector. It's 10 down from the last, you know what I'm trying to say. Anyways, the first pin for the second half of the board is here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which is 1, 2, 3, 4, 5, 6, 7 pins from the bottom. 1, 2, 3, 4, 5, 6, 7. There's no, it's blank. So I think in production, someone actually just soldered a wire on the wrong tag, realized and moved it over where it should have been, because there's a missing wire on the exact same correlating tag on both channels. And this tag here that's missing, like I said, one channel has an extra pin. See how there's 5 pins and 1 pin there, and 4 pins and 1 pin there? That correlates to that pin there. The channel that's got the one less pin, that's that. And that's the master channel. The slave channel's got the extra pin, so you can hook it up to the master channel, put it in auto tracking. So I actually think that's correct. So I don't think whatever they've done is on that connector, and if it is on that connector, that it's probably not that pin, but it's a wire that's been swapped around or moved around. Or, you know, it could be something in the front panel that they've moved around. But I've honestly stared at all the wires in the front panel, and the color codes, they're all color coded, and everything looks identical side to side. You know, like one side might have, say, like 2 orange wires with a blue stripe on them going to one side of a switch. The same switch on the other side's got, say, 2 orange wires with a white stripe on them. You can tell that it's all, you know, like how it looks, how like it was, you know, supposed to be how it's supposed to be. So I really don't know. It's got me really baffled, you know. So like I said, what I think I'm going to do this quickly is we'll power this up, and we'll just have a look across the resistors in the divider networks, the voltage on these 4 op amps that look at the current resistors and the voltage inputs and that. We'll have a look at the outputs of these op amps that have something to do with the references and the voltage control circuitry. And the other thing I was going to do, because I haven't measured current across this reference on that side, and I haven't measured current across both references. we'll measure the current across all the references and see, you know, is one reference missing a ton of current, for example. Yeah, so there's a few things that I want to look at, and they'll just tell me basically if someone's gone and messed around with the wiring on here or changed stuff around that I need to put back to how it's supposed to be. Because I've just had that feeling all along that there's still something I'm missing that's, that someone's done that's not right. And, after all the stuff I've uncovered slowly in here, I don't mean me picking up things I should have picked up if I paid more attention in the first place. I'm talking about all the random things like the wrong value pots and under wattage resistors and so many resistors that are changed that we don't even know if they're the correct value. Just all those sorts of unknowns. There's enough of them, and there's odd transistors in there. There's all different op amps from different years. It's just, yeah. You can tell people have been, what am I doing? In and out of here so much. So let's have a squeeze. So I'll put it on. I'll set both voltages. Oh, what have I done? Oh, God, you gotta be shitting me. Wait, no, that's the right way. Huh? I'm not kidding you guys. Everything is connected the right way. I thought for a second that I didn't twist the cable around, but that's right. Let's double check. No. That was my bad. Well, at least that doesn't blow the unit up. Could be worse. If I put the other cable in the wrong way, then we've got trouble. Alright, so I'm going to put the voltage and the current to full, so both sides, essentially should have roughly the same voltages across everything. Both the meters are on volts, the current's turned up, the voltage is turned up, and it's in independent mode, most importantly, because we don't want one side linked in with the other, potentially dragging down voltages or resistance values or whatever. So, let me move over for you guys like that. Right. So across this resistor, we've got 11 volts. Across this one, we've got 11.21. See, that's what I'm saying. I'm not worried about little things like that. 4.329. 4.325. 5.1. 5.097. That's the reference voltage across that. I know exactly where that's coming from. Alright. Op amp. We'll look in between the negative rail here and the output. 16.95. Yeah, no, that's close enough. It is a little bit different, but see, that's the thing. That's the side that comes up slowly, and that's the op amp that it's heavily responsible for the output voltage. I can tell you that because every time I've cooked it, I've ended up with the wrong output voltage or no output voltage or full output voltage. So yeah, how much different was that again? I don't think it's much, like 20 millivolts. Yeah, it's only like 20 millivolts. Alright, I guess we can sort of ignore that. Let's look at the outputs of the op amps first. 8.93, 19.73, 8.88, 19.78. Alright, let's just have a look. I know it's probably quite unlikely, but let's just see if there's any voltage slapped across the inputs of one that isn't on the other. So as you'd expect, millivolts. Well, that's actually quite interesting. Wait, which was that one I just checked? I didn't check both of them, didn't I? 0.758. 0.4. Absolutely nothing there. Right, so that's the op amp that looks at voltage. Well, that's interesting because it's the voltage that comes up slowly, and that's on the slave channel. Why is the input offset voltage not present? Interesting. Wow, 1 millivolt. Oh, sorry, 0.1 millivolts. Yeah, no, I find that hard to believe that there's 0.1 millivolts there. See, all the other measurements we've just been looking at, 20 millivolts, 200 millivolts, it's nothing in terms of difference. These are the inputs to op amps. So 1 millivolt is all the world difference. Well, these things have got a few millivolts input offset voltage. You know, we don't know. They're not trimmable, so 3.7 millivolts versus 0.1. Right. That's suspicious. I'm going to put it into auto tracking mode and we'll see if the voltage comes across here. No, it does not. What about here? Stays the same. What about the current op amp? Oh yeah. Yeah, that's actually real interesting. I'm not gonna lie. Okay, so it points me in the right direction because, like I said from a few videos in, there's something different about the slave side to the master side, and it just doesn't seem right. Oops. Let's compare the because that was the voltage op amp. Let's compare the reference voltage. Sorry, the current, because I've only ever measured this reference. You know, I said the bottom board they got 37 milliamps. I never actually compared both of them to make sure that they both have 5 milliamps, so I don't remember doing it anyway. Let's see if one's really, really low and the other one's not. Because I don't know. I never checked. So this reference, it's got 5 milliamps on it, 6 milliamps. What's this one got on it? Okay, same thing. Let's just see if there's anything drastically different on resistors. Because these are all input dividing down resistors. They're like all in the input circuitry stage. Because I've traced out I have traced out a few things in here. Interesting. Let's have a look at the voltage drop on all these. Oh, that's right. I traced the 2.2Ks out. I thought they were drop resistors for the Zenas. They actually just go across the capacitors to load the rails. Oh my god, I'm in fucking current mode. Well, at least that literally just goes across a capacitor and a freaking power supply rail. We didn't do anything wrong there. Well, if I held it there, I would have done something wrong. Would have no diodes left. 19, 29, 19, 29, 29, 19, 29, 19, 29, 29. Yeah. What about these ones that haven't been changed? 19, 19, 18, 18. Well, 8.89, 8.78. Alright, well that didn't prove out to be too helpful. I guess I'm going to be putting LM301s back in there and then just changing two at a time and trying to contact that company to get a schematic. In the meantime, I'm still going to just have a quick one last trace out on those 4 pots where they go back. Not on this video, just in my own time, just for curiosity's sake, but I just thought I'd come back to this and have a look at it one more time before I go and do what I'm going to do, which is literally put LM301s back in there and then swap them 2 at a time, basically, and see what we can get to work in there. I just don't want to do all of them. Like, I don't want to change them all at once unless I find, if I had a part that I was 100% certain would work in there. Like the LM358s will definitely work in there. I don't doubt that, but they are so much slower than the LM301s. I just wouldn't do that. So yeah, I guess that's all I can really do is try and contact that company, see if I can get a schematic, have one last look at the front panel wiring just to make sure that there's nothing that is a bit odd there, you know. And try and contact that company, the Tanamera Tech, if you're watching, thank you again, told me about that Scientific Electronics has now become. So I'm sorry if this series has been unproductive and not gone anywhere yet, but I tell you what, it's going to go somewhere soon, because it's either going to end up going back to its original form, like I said, and we'll just do one upgrade at a time, or I'm going to end up with schematics and I'll know what's going on exactly anyway. But yeah, with that being said, I'm going to sign off here for now. I might do something else and upload that tonight, because obviously I'm going to have a quick look at it, but I don't really feel like working on this tonight. It's already late, it's 11:30, so I might do something small. I might just go to bed, I'm not sure. But with that being said, thank you for watching, and I'll see you in the next one.